Hello everyone, my name is Thankam and this is the presentation for my final project, Twitter Data Analysis using ELK-Stack. I'm going to begin with a brief introduction to ELK-Stack. ELK-Stack is a collection of three open source technologies, Elasticsearch, Logstash, and Kibana. Elasticsearch is a NoSQL database with very powerful search capabilities along with very good scalability. And Logstash is a tool through which you can extract data, transform them, and load the data to and from different sources. This is known as an ETL, extract, transform, load. Logstash can accept inputs from S3 buckets, SQLite databases, from Elasticsearch, Twitter, from flat files, CSV files, etc. And it can perform some transformations on this data, and then finally it allows you to store it in different output sources. The output source can be Elasticsearch or S3 buckets or databases, etc. So in my case, the input for my project is Twitter data, and the output is being stored in Elasticsearch. And the last technology in ELK-Stack is Kibana. Kibana is a web-based data analysis and dashboarding tool for Elasticsearch. It basically allows you to make some sense out of the data that you just collected. Next is project goal. As I mentioned earlier, the input for my project is Twitter data in real time. So my goal is to analyze this data in real time and answer a few questions based on them. A single tweet can have several hundred attributes to it, like who is the username, what was the language that it was tweeted in, what is the location of the user, what is his time zone, was it a retweet or was it a new tweet, etc. So based on all this information, my analysis will be based on a few set of keywords. For example, I'll be looking at certain positive sounding keywords like I'm happy or I'm relaxed, excited, etc. The keywords can be based on hashtags too. So based on these keywords and by using Kibana, I can tell that this particular area has more number of positive keywords in their tweets as compared to this area. This is a high-level project flow of what I just mentioned. So I begin by connecting to the Twitter API. I will gather tweets using Logstash, using Twitter as the input, filter the tweets based on certain list of keywords, store it in Elasticsearch, and visualize it using Kibana. Next is an overview of the environment and tools that I have been using for this project. I have used Amazon AWS EC2 service for creating 3 instances from a Linux AMI. And I use one instance for Elasticsearch, one for Logstash, and one for Kibana. I'm also using a plugin for Elasticsearch, which is known as Head plugin. So we'll look at it in a minute. Next, I'm going to go in detail on each of those technologies in the ELK-Stack. First one is Elasticsearch. Elasticsearch is a NoSQL REST JSON-based API technology. It's schemaless and it's highly document-oriented. It allows you to do rapid full-text searching using inverted indexes, ad hoc querying capabilities, and it is built on Apache Lucene project. Next, this is an overview of the configuring Elasticsearch config file, which is known as Elasticsearch YML. Setting up Elasticsearch is very straightforward. You can download them from tarball or a URL, and then extract the data into a folder, and all you have to do is change the Elasticsearch YML file. So you have to provide the cluster name, which I've named it as Elasticsearch. You could have many different servers in your cluster, but in my case, I only have one. And since my environment is AWS, I have to provide the Amazon AWS credentials, which is pretty standard. I have to provide the region, the type, the tag name, etc. Next one is Logstash. Logstash is used for log collection, transformation, and forwarding, as I've mentioned. So log collection is the most popular use of Logstash. You can use it for analyzing any kind of logs, web server logs, application logs, error logs, etc. But you can also use the Logstash for analyzing any kind of big data. Like in my case, I'm using it for analyzing some Twitter data. And Logstash is based on JRuby technology. And this is the high-level flow of Logstash. It accepts the input from several different sources that I've mentioned here, filter them using all these filters, and put the output in storage, different storage like Elasticsearch, File, DB, S3, etc. This is an overview of the configuration file of Logstash. Setting up Logstash is also very straightforward. You can download them from Tarball, extract them, and change the config file. You can name the config file anything you want. I have named it as twitter.conf. So it'll have 3 sections: input, filter, and output, and we'll look at each of them in detail. So this is an overview of the input section of the config file. So as I mentioned, my input is Twitter. So this is how you access the Twitter API. So codec is the format that you want the data to be streamed in. So I have mentioned JSON format. And this is pretty standard for accessing any Twitter API using the code. So all you have to do is go to the Twitter application and create an application there, and you can download the keys and the authentication tokens. The message format is again JSON, and this is the keywords that I've been mentioning. So I'm looking for keywords like happy, relaxed, elated, excited, etc. And full tweet is true, meaning I'm asking to give it the entire tweets. If I don't do that, I will only get a subset of the tweet parameters. So these are the other inputs that Logstash can accept, like S3, SQLite, file, syslog, XMPP, etc. This is the filter section of the config file. So you can have several different combination of filters. Filters can have grok, grep, geoip, ruby. Mutate is another filter that I'm using here in my code. So what this does is, if my data is bad that is being streamed in, then it could result in a grok parse failure. So I'm using the mutate filter to just extract those data out, so my data is more cleaner that way. So this is an example of a filter that I'm using here. And there are other filters, and you can use a combination of all these filters here. And grep is very useful, and you can even provide regex patterns in grep filters. This is an overview of the output section. As I mentioned, my output is Elasticsearch. So I provide the host for the Elasticsearch URL here, which is in my case, it would be the public IP of my Amazon AWS instance. And the protocol is HTTP, index type is tweets. You can provide any name here. And I'm also putting the output to std out so that I can see and I can show you. So which is very useful for debugging purposes. And these are the other outputs that you can put data into. S3, you can even send it to emails, CSV, pipe, etc. The last one is Kibana. It's a web frontend for analyzing data using dashboards. You can visualize the data using dashboards. So this is an example of how a dashboard would look like. So we can look that in detail later. So this is how you can configure Kibana to talk to Elasticsearch. You edit the kibana.yml file after installing Kibana from Tarball again. And you specify the port, the host is 00, Elasticsearch URL. So by default, the port is 5601. You can change it to 5602 as in my case. And then I provide the Elasticsearch URL and the port number in which Elasticsearch listens to. By default, it's 9200. And next is the demo. So now that we have the data loaded, I'm going to quickly look at the Elasticsearch Head plugin. Elasticsearch Head plugin is a very useful web frontend which you can access by just appending plugin/head to the Elasticsearch URL. And as you can see, our one server in the cluster is loaded, and which has got 5 different nodes, and the indices has been created successfully. If you look at here, and from the browser, you can see that all the data is being loaded. This is my index name, which I have provided configured in the config file. So now we can visualize this data in Kibana. So to access Kibana, I will use the public IP of the Kibana server, and I'll use the port which we have specified in the kibana.yml file. So initially my data will okay. So I'm going to begin by showing my 3 AWS servers in EC2. I've got 3 servers here, one for Elasticsearch, Logstash, and Kibana, and I have tagged them all with the same name, ELK prefix. And for the purpose of the demo, I have created a security group for all these 3 servers, which have all traffic open to inbound and outbound. So, and I have got 3 terminals open, one for each here, so that I can SSH into each of these servers. So this is for Elasticsearch, the terminal. So as you can see, I'm in the Elasticsearch directory where Elasticsearch is being installed. And if you see the ls here, you can see the Elasticsearch YML file, which is the configuration file that I was mentioning in my slides. So I'm going to go ahead and start the Elasticsearch service using the command. So I'm in my Elasticsearch terminal, so I'm in my directory where Elasticsearch is installed. So if I'm doing an ls here, I can see the configuration file. So this is the Elasticsearch YML file which I was mentioning in my slides. So I'm going to go ahead and start my Elasticsearch service. So my service has started okay. So you can also verify the service start using the browser by using the public DNS and the port number. So this is how you do that using the URL, and it looks like the service is fine because I can see the status to 200. So I'm also going to show the Elasticsearch head plugin that I was mentioning earlier. So you can access the head plugin using the URL, appending the URL plugin head to the Elasticsearch URL. So as you can see, there are no indices here, which meaning there is no data yet here in Elasticsearch. So if I had any data, you could see an index here, and also you could see the data using the browser. So let's start pulling in data using Logstash. So next one is Logstash. So I'm in my Logstash terminal and inside the Logstash directory here. So I'm going to show the config file that I was mentioning, which has the input, output, and the filters set up. So as you can see, I have the input with all the Twitter credentials, the filter, and then the output. So I'm going to go ahead and start Logstash so we can start pulling data from Twitter. So let's give it a few seconds. So this is the log warning. So in a second, you can see data loading. So remember, we have provided the format for the data as JSON lines. So that's what you'll be seeing here in the stdout. So it has started loading. So let's give it a few minutes so we can make sure to have enough data necessary for our analysis. And if you don't stop it, this is going to continue forever because it's pulling data in real time from Twitter. So I have stopped the Logstash. So it looks like we have enough data now. So let's now go ahead and refresh the Elasticsearch head plugin. So as you can see, we have one new indices here, which means I only have one server in my cluster, which has 5 different nodes. Now if you go to the browser and refresh it, you can see all the data. So each entry in here will be a tweet. So this shows that I have around close to 1700 hits, 1700 tweets. So that should be enough for analysis. So now I'm going to go to Kibana to show the data. So I'm in Kibana. I access Kibana using my Kibana server's public IP and the port 5602, which we configured using the YML file. So as you can see, this has already recognized my index pattern known as logstash star. So we can start looking at the data by using the time picker. So that will let us know this much data has been accumulated in this time frame. So I'm going to pick timestamp which is available here and say create. So now if you go to discover, so as you can see, I have the same number here, 1747 hits. So this is the time frame for each of those. So I have this many 443 in this particular in time frame in milliseconds, the next one and the last one. Now I'm going to display this using dashboard. So for that, you go to the visualize section. Let's say I want to display them using pie chart. So you pick pie chart from a new search. So now you have just a pie, but no slices in the pie. So I'm going to split this into slices based on my keywords and based on my the time zone of the user. So you do that by using the split sizes, and the aggregation I'm going to use terms, which will allow me to pick whatever field that is available in my tweet. So I'm going to pick user time zone, and I need let's say 20 data. So I need top 20 records that have positive tweets in a particular time zone. And now I say apply. So this shows that Canada is green. It has got 594 tweets. US has got 517 tweets, etc. So this concludes my demo, and so this shows that using a very few lines of code and some very easy setup, you can actually use ElkStack for analyzing really big data. Thank you.